Well, here we are now exploring the square root property. Isn't this exciting? We are going to connect the quadratic equation with its quadratic graph. So our first example we're going to look at is the function y equals x squared minus 9. So just like back in the pre-algebra days, we're going to actually make an xy table, okay? So we're going to get started together, and then I'm going to have Mr. Kleiber stop the video, and you're going to finish the table on your own. So let's say our first x value is 4. So we're going to evaluate the function. So we want to find out what is the value of y when x is 4. Well, we are going to go 4 squared minus 9. Well, we know 4 squared is 16. So then 16 minus 9 is 7. So when x is 4, y is 7. So let's go over to the graph and graph that. So we'll go over 4, 1, 2, 3, 4, and then up 7, 1, 2, 3, 4, 5, 6, 7. So there is our first point, okay? I'll do one more with you, and then you're going to finish the table with your partner. Let's do a negative. So how about negative 1? So we're going to substitute negative 1 for the x values. So it's going to be negative 1 squared minus 9. Well, we know negative 1 is 1. Negative 1 squared is 1. 1 minus 9 equals negative 8. So we're going to go over negative 1 and then down 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Fantastic. Now, in your pairs, I would like you to complete the rest of this table. So figure out for these x values what their corresponding y value would be, and then plot those points. And we'll come back and see how you did. Well, I hope that your table looks like mine does. So why don't you take a minute and check out the y values I got, and then the ordered pairs that I got, and see if your answers are correct. Now, I hope they are. If they're not, then you may need to pause the video and correct your answers. Now, let's talk about the graph. We know that the graph of a quadratic equation is what we call a parabola. Whoops, let me get in my pen mode here. Okay, so this is a parabola. Now, it looks like the word parabola, but we pronounce it parabola. Okay, now for this parabola, if you notice it has like a U-shaped. Now, you have to be careful when you draw it because you don't want it to draw it. It's not linear. It's curved. So notice how I'm kind of, whoa, that didn't go off so well right there. You're kind of curving it. It has growth that way. And it keeps continuing in the upper direction. And then when we come down here, notice it's curved at the bottom. It's not a V. It's more like a U. Okay, so you should be drawing in your parabola right now. Now there's some very important vocabulary words that are associated with the parabola. The first word I want to talk about is the vertex. So the vertex is the point right here at 0, negative 9. Now there's a lot of ways we can describe the vertex. Like for example, the function, if we go from left to right, it's decreasing, and at the vertex, the function begins to increase. Okay, it's the point where the function changes direction, the vertex. Okay, another really important vocabulary word is that parabola has what we call an axis of symmetry. There is a line that can be drawn on every parabola. So this is called the axis of symmetry. So you should be labeling this on your graph also. Axis of symmetry, where when I draw in this line, it causes the parabola to be symmetrical. So in other words, if I were to fold this parabola along that line, it would be balanced or proportional on either side. Just like if you think about, there's a lot of things in nature that are symmetrical, even our bodies. If we were to draw a line of axis of symmetry right down the middle of our body, you'll notice that it is symmetrical, the right side to the left side of our body. So we have a vertex, we have an axis of symmetry. Other important vocabulary words is here the x-intercepts. Okay, so notice these x-intercepts. Now, these x-intercepts have a couple different names that are used for the parabola. Of course, we can call them the x-intercepts, but another common word is the roots. These are also called the roots. So this parabola has two roots. It has a root at 3, 0, comma, and then it also has another root at negative 3, 0. So I hope you're clearly labeling your diagram, your parabola. Great. Now, if we look a little bit further down on this worksheet, so if I scroll it, so question 2 says, what are the x-intercepts of the graph? Well, you already know that. We talked about the x-intercepts are at 3, 0. Now make sure you write them as an ordered pair because a point always has two parts, an x-coordinate and a y-coordinate. So those are the x-intercepts of the graph. Now we're going to make a ooh-ah connection. If we know that this function is y equals x squared minus 9, and if we look at it and compare it to the line y equals 0, like, wait a minute, Ms. Kleiber, what are you talking about? Well, if I go back up here, the graph in red is y equals x squared minus 9, right? We graph the y equals x squared minus 9. Okay, well, if I also graph y equals 0, well, we know y equals 0 looks like this, right? It's a horizontal line on the x-axis. Okay, now if you check it out, what are the solutions? In other words, where do these two functions intersect? So we can see that the two functions intersect right here at -3, 0, and 3, 0. Okay, Ms. Kleiber, but what's so cool about that? Well, we're going to connect the graph with algebra. Because if we know that y equals x squared minus 9, and we know that y equals 0, then we can say that 0 equals x squared minus 9, right? Since they both equal y, then they both must equal each other. Well, 0 equals x squared minus 9. If I add the 9 to both sides, we get x squared equals 9. Now, can you figure out what number would make that equation true algebraically? Go ahead, go ahead. I'm hearing your responses. You're saying, well, Ms. Kleiber, 3 squared equals 9, right? Because 9 equals 9. And also, -3 squared is 9. So 9, excuse me, 9 equals 9. So now to make the conclusion here, how are the quadratic equation and the graph of the quadratic related? So the quadratic equation, the solutions were 3 and -3. Well, where do you see those points on the graph? Well, you see those graphs as the x-intercepts. So it looks like the solution to a quadratic equation is the x-intercepts of the parabola. Oh, you've got to be kidding me. I know. Isn't that great? I thought so myself. Now, does this work for every... Okay, now if you flip to your next page, we're going to explore this same idea and see if it works with the zero product property. So again, kind of like what we just did, I'll do one x and y value for you, and then you'll work with your partner and fill out the rest of the table. So let's do, if x equals 4, what would y equal? Well, we would substitute an x for 4 everywhere I see. Okay, now we're going to do our math. So 4 squared is 16. 16 plus 8 is 24, that's right. 24 minus 3 is 21. So when x equals 4, y would equal 21. Now let's do another one that's a little more challenging. How about, let's do -1 again. Now remember, wherever there's an x, replace it with -1. So be careful on this. Remember, it's -1 squared, and then it's plus 2 times -1 minus 3. Now be careful with your integers here. -1 squared is 1 minus 2 minus 3. So 1 minus 2 is -1, minus 3 is -4. Now, I notice in graphing this, 421, how am I supposed to graph 21? That is ludicrous, Ms. Kleiber. You're right. I kind of agree with you. So you know what? Let's graph the numbers that actually fit on this coordinate plane. Like, would 3 fit? Let's see. I'm not going to put you in too much pain here. 3 squared times 2 times 3 minus 3. So we get 9 plus 6 is 15. 15 minus 3 is 12. Still a little high. How about 2? 2 squared plus... Why am I doing this whole thing for you? You baited me, didn't you? 4 plus 4 is 8 minus 3 is 5. That's decent. So would you finish with your partner completing the table and then graph the parabola? Now remember, your parabola must have a vertex and an axis of symmetry. Okay, ready, go. Okay, well here is my table of values, and let's see if you agree. Did you get the same x values coordinating with the y values? And then when you made the graph, does your graph of your parabola look like my graph? So take a minute to check that out. Excuse me, this is live audio, folks. So let's talk about the different parts here. Now we know that the graph of a quadratic equation is always called a parabola. So we can label this as a parabola. And a parabola always has a couple of key features. The first feature is it must have a vertex. Now remember, a vertex is the ordered pair, the point, where the parabola changes direction. So notice from left to right, it's decreasing, and then at the parabola, it changes to increasing. So that is at the vertex. Now it will also have an axis of symmetry. Now if you notice here on our axis of symmetry, the axis of symmetry will always be a vertical line, and if you were to fold along that vertical line, it would be symmetrical, and the axis of symmetry goes right through the vertex. So since it's a vertical line, the axis of symmetry equation is x equals -1, because it's the same value as the x value of the vertex. And in this problem, we have two roots, or two x-intercepts, right? So one of them is 1, 0, and then the other is -3, 0. Now this is the graph of our function. Now let's see if we can connect this graph to the algebraic solutions, just like we did in the last page. I know, it's exciting, isn't it? Okay, I knew you'd be excited. Here we go. So, what are the x-intercepts of the graph? Well, the ordered pairs are -3, 0, and then the other x-intercept is 1, 0. Now, how do those intercepts relate to the solution? Well, we know that the function is x squared plus 2x minus 3. And if I want to find where that crosses the x-axis at, well, the x-axis is y equals 0. Since they both equal y, therefore we could say 0 is equal to x squared plus 2x minus 3. And now we can solve this problem algebraically. Doesn't this remind you of the zero product property, where it's set equal to 0? Now we're going to write it as a product. So x times x is x squared, but what multiplies to -3 and adds to 2? Come on, I know you got it. That's right. Plus 3 minus 1, right? Because 3x minus 1x is 2x. Excelente. So, if we then continue solving this problem, then our solutions are x plus 3 equals 0, so therefore x equals -3, and x minus 1 equals 0. So then the other solution is x equals 1. So the algebraic solutions match the x-intercepts of the graph. So how is the quadratic equation and the graph of the function related? Well, the solutions to the quadratic equation are the roots of the graph of the quadratic function. Now, your next task, now those of you meeting for just one session, so that would be my first section of Algebra 1, your homework now is going to be due to the next 2 pages. So you're going to do Skill Builder 5 on page 3 and Skill Builder 6 on page 4. Now, in my double block class, why don't you take about, a little bit of time and just start working through some of these problems with your partner. And then we'll come back and talk a little bit more about some exciting other things with quadratic equations.